What is going on, guys? Welcome back. In this video we're going to learn how to do proper type hinting in Python to make your code more professional. So let us get right into it.
It's not a game, it's a rage thing.
Alright, so we all know that Python is a dynamically typed language, which means that we don't specify the data type of a variable when we create it, and this means that I can do stuff like that. I can say a equals hello, I can say a equals 10, I can say a equals true, and I can print a in the end, and you're going to see that this works without a problem. I can also print a in between. That's not a problem. We don't have the problem that a has different data types across time. We have a string first, and an integer, then a boolean. Doesn't really matter. Python allows us to do that. Still, it is more professional, and sometimes we should do it. We should provide type hints in certain contexts. So it can make sense to provide type hints, which, however, do not change how Python works. So, for example, I can provide a type hint that a should be an integer, and I can still assign to a the value hello world. So this is how you do a type hint. I say a should be an integer, but I can still assign the value hello world to it, and I can still print a, and you're gonna see that without a problem, I get hello world as a result here. Yes, PyCharm underlines this and says, hey, expected type int got string instead, but still Python executes the code without problems. I can do that. This is not a problem. This is only for documentation. This is only for readability. This is only for other developers and for certain tools to see that the type hints are not violated. So Python doesn't change because of that. Just because I say this is an integer, it doesn't become an integer magically. It's still a Python object that can basically be everything. However, we can use tools like MyPy to verify the integrity of the type hints, and for that we open up the command line and we type pip install MyPy. And then, as far as I know, we just have to type MyPy and the file name. So I'm going to navigate to the Py directory. In my case, I'm going to navigate to current, and I'm going to call MyPy main.py. And in this case, we can see incompatible types in assignment. Expression has type string. Variable has type int. One error in one file. This, again, doesn't prevent me from running this code. I can still run it, no problem. But MyPy finds violations. And the whole purpose of type hinting is essentially just to make code more readable, more predictable, and also for certain environments, for certain applications like MyPy, or also for some web frameworks or something like that, a type hint is actually taken seriously, and if you provide a wrong type hint, you're gonna have some problems. So it's not completely useless, but the applications need to check for that proactively, because Python does not forbid you to do something like that. You can still do that from Python, right? If the library prevents you to do that, that's a different thing, but Python allows you to do that. And this is what we're going to talk about today, how to do proper type hinting in Python. And you saw already the basic idea. We have a variable name like mystr, and we specify that this is a string, and then we can assign a string value to it. I can do the same thing with my int equals 20, for example. And now if I go into the command line and I check with MyPy, you can see success, no issues found in one source file, because now this is not violating the type hinting. And I can go ahead now and also create a simple function. I can say, for example, my underscore typecast, my own typecast here. I'm going to take a value in that is a string, and I'm going to return an int. This is how we do the type hinting for a function. I say that the parameter value should have the data type string, and the return value of the function after this arrow, as you can see here, is an integer. And all I want to do here is I just want to return int of value. And what I can do now, of course, is I can just print my typecast, and I can pass a string with the value 20. Now this is, of course, a number in here, but this is a string from the data type. So this is fine, and I can now run this, and you can see that I get 20 as a result here. Now, the interesting thing is that I can also pass a number in here without problem, so I can also remove these quotations, and still I'm gonna get the same result. However, if I now run MyPy, you're going to see one error. Argument to my typecast has incompatible type int expected string, whereas if I do that with quotation marks here, it still runs. And if I check we see no issues found in one source file. So this is how you can do that. What you can also do is you can say that, for example, if we don't return that, but if we print the result here, this function doesn't return anything. So what you can do here is you can just say the function returns none. This is the same, of course, as just doing that, but it's more explicit. And as we know from the Zen of Python, explicit is better than implicit. So this is more professional to just say, okay, this function doesn't return anything. So at least we know for sure. And I think one space is missing here. And then we can just go ahead now and say my typecast, and I can apply this on 700, and then it works. Now, one thing that type hinting does not do is it does not validate, obviously, whether the code is going to produce some problem, right? If I pass a string here with hello world, this is going to cause an issue when I run it, because we cannot convert this, we cannot typecast this. However, if I check with MyPy, there are no problems because this is a string. So MyPy only checks for the actual type hints. It doesn't check whether it makes sense what I'm passing in here. It only checks, is this a string or not? So that is that. What else can we do? We can also do the same thing with lists. We can say my list, for example, is a list of integers. And then I can say, okay, this is 1, 2, 3, 4. Then I can say my list 2 is a list of strings. And here I can pass a list of strings, hello world. And also I can do something like my list 3 is a list of integers. And then I can do something like 1, 2, 3, 4, 5, 6, and so on. As you can see, when we provide type hints, we cannot use a list with multiple elements, unless, of course, we use some special types like list any or something like that. But if we provide a specific data type, this data type is the only data type in that list. So I cannot go ahead and say, hey, in here. Even though Python allows me to do that, MyPy will say this is a violation, because you can see here that the list item 4 has incompatible type string, expected integer. So this does not work. If I remove this, you can see that this is not going to produce any issues. So this is some basic type hinting here. Let me show you also how to use that in a function. We can use here the list function. I'm just going to create a function where I take a list of integers and I'm going to return none here. So all I'm going to do is I'm going to iterate over that list. So for element in L, I'm just going to print that element. Now, the interesting thing here is that I can now again call this. Actually, I don't have to print this. I can now call this here on a list 1, 2, 3, 4, and it's going to work, as you can see. But I can also call this on a list, which is not a list, but just a string. I can call this on hello world, and then it's going to print the individual characters of hello world, because hello world is also a sequence, a string is also a sequence. But if I call MyPy, again, we're going to see we expected list int, but we got string. This is not okay. If I delete this, everything's fine again. So you get the idea here. We can provide type hints. They're important for consistency. They're important for readability, for professionality, but they don't change the Python code unless, of course, you're using libraries that deliberately pay attention to the type hints and act differently based on what we're doing. And last but not least, before we go to some more advanced stuff, I want to show you here, we can also define dictionary. So I can say myDict equals, and then I can specify that this is a dictionary with the string as the key and the int as the value. And then I can just say, hey is mapped to 1, world is mapped to 2, and so on and so forth. So this is how you do that. And I think we can also do sets, right? So I can say my set equals, or my set is a set of integers, and then I can just specify 1, 2, 3 here. So that's the most basic type hinting that you can do in Python. What we can also do now is we can create our own custom types, and for that I'm going to delete all of this here. And we can say, for example, I want to have a type TCP dictionary, so TCP underscore dict, and then I'm going to say that this type is just a dictionary where a string is mapped to a list of other strings. And the basic idea here is that this is a more complex type, so instead of specifying this all the time, I can just say that the type of my variable is a TCP dictionary. And this would look like that. I can say my TCP underscore dictionary is equal, or actually I have to provide TCP dict as a type, is equal to, and now I can say, here I want to have the main server, and the main server has the list of values, I don't know, some IP address, 1.1.1.1, port 80, and yes for, I don't know, active or still available or something like that, still being maintained. Then what I can do is I can say other server is, I don't know, 2.2.2.2, port 99, no, whatever. So I basically provide just a key value pair of a string or multiple key value pairs of string mapped to a list of strings, and this is then a TCP dictionary. This is an ordinary type that I now created, a custom type that I now created. So I can go ahead and define a function that says print TCP dictionary. And of course, what I want to have here is, let's just call this value. I want to have this TCP dictionary here as a parameter. And then what I'm gonna do is I'm just gonna iterate over the items. So I'm gonna say for key value in, maybe value is not a good, let's call this DT. In dt.items, what I'm gonna do is I'm gonna say print the name of the server is gonna be the key, and then I'm gonna say, oh, what happened here? Then I'm gonna say the IP address, the port, and active. Maybe also let's put this in uppercase. I'm gonna be value 0, value 1, value 2, like that. And then I can just print a TCP dictionary, my TCP dict. And you can see that this works without problems. Now, also, when I run MyPy, you're going to see no problems because everything's consistent. The problem is now, from a Python perspective, I can pass whatever I want here. And I can also pass something that is not violating the typing. So I can do something like other underscore dictionary is going to be a dictionary where I say, hey, is mapped to a list of H, or maybe just hello, and maybe another 1, 1, 2, 3, or something like that. So this is actually consistent because that is also TCP dictionary by definition. It's a dictionary which maps a list to a string, like a list of strings to a string. So that's no problem. And I can also just call this function here. And when I now check if this is violating anything, nothing is violating anything. So I can run this, and actually I passed the wrong dictionary, sorry. Let me see again. No violation, no problem. But when I run this, you can see list index out of range because obviously, as I already mentioned, MyPy doesn't check if the code makes sense. It just checks if the type is valid, and this is the same type as this. Now let us get to some more advanced type hinting because Python offers us a built-in module called typing, which allows for more complex data types. So I can say, for example, from typing import, and then I can import a couple of data types, for example, any, or sequence, or callable, union, optional. We're gonna look at those now. There are a couple more, but you can look them up if you want to. We're gonna focus on those 5 here. And most of them are actually quite self-explanatory. The name says already what it's doing. For example, any, I think any is quite clear. Basically, when the type hint says any, you can pass anything. So if I say my function here, the value can be anything, and the function returns anything, and then I can just return value times 2. This can work for a string, so I can say my function hello, and then I can say my function 2, and I can say my function 1, 2, 3, and we're gonna see that all of this works in Python and all of this works in MyPy, no issues, because anything is literally anything. The reason you specified, because you can also just, not specify it, but the reason you specified is because you don't want to keep other people guessing. So if you're using type hinting, again, this is more explicit, it's less implicit, so people exactly know. They don't have to guess whether this function can take anything. They know that when you provide any, it takes any. So that's what you can do here. We can also look at the sequence now. The sequence, as the name already says, is a sequence, which is a string or a list or a list of integers, a list of strings, whatever you provide. Whatever is a sequence will be processed by this function. So sec, and then I can say, for example, for x in sec print x. We can iterate over this, and then I can just say print, actually not print, my function, and I can pass the list 1, 2, 3. I can pass the list hello and world, and I can also pass a string, because a string is also a sequence of characters. And you can see, first of all, this works in Python, and this also works here in MyPy. So we don't have an issue here because that is consistent. Now, I think that when we pass, if we pass a set, this is not going to work because a set is not a sequence, I think. I'm not sure if it's actually going to work programmatically. So if it's going to work in, yeah, it works in Python, but MyPy is going to say that this is not a sequence. And I think the same is true for the dictionary. So if I map A to 1 and B to 2, I think this is also not a sequence, at least not the correct sequence, if at all a sequence. So this is what it can do with the sequence keyword. With a callable keyword, we can pass functions. So I can say here, callable, and then fct, and then I'm just gonna call the function that was passed. So for example, if I have another function here, other fct, and this function is just gonna print hello world, like that, then I can call my function, and I can pass other function as a parameter, and you can see no issues, and this also works in Python. That is that. Now, those two are actually kind of interesting, union and optional, because union is what allows us to have multiple types, but not all the types. So not any, but for example, we can say here that I can have a value, and this value should be either an integer or a string. So what I can do is I can pass here a union string int, and then I can say, okay, this returns none. What I want to do here is I want to print the value times 2, for example. Whatever you want to do with that, you can make up more interesting examples, more useful examples. But essentially, we can just call the function then. I can call it on 10, and I can call it on hello. This works programmatically. It also works with MyPy, because this is either a string or an integer. If we were to pass a list, for example, this will not work. 1, 2, 3. It will work in Python, but it will not work for MyPy, because you can see this has to be union string int, but it's a list int. That's not acceptable. And then for the optional, it's actually also quite self-explanatory. It basically indicates that a parameter is optional, so we might have a default value for it. For example, I can say here value int equals 5, and then I can say that this returns none. Then I can just print the value here, and then I can call the function with 10, or I can call the function without a parameter. I can run this. I can also check with MyPy if that is fine. There you go. And this works, but it's not explicitly saying that it's optional. So what I want to do here is I want to specify the type optional to make it more explicit. So I say, okay, this is optional 5. Still works the same way, doesn't produce any problems. Still works the same way here in MyPy, no problems. But we explicitly say it's optional. One thing you need to keep in mind, though, is that if you just say it's optional and you don't provide a default value, this does not work in Python. Because just because you say it's optional doesn't make it optional, it just hints. This is just a type hint, doesn't change anything about Python's way of working. If you don't provide a default value, the value is not optional. It's only optional if you provide a default value. So you need to still provide a default value even if you say it's optional. I'm not sure if we're going to get a type violation, missing positional argument. Okay, but I think this is not a type error. This is just Python. But yeah, you can see just providing this is not enough. Now, last but not least, we're going to take a look at generics. Generics are a very interesting concept, and in order to use it, we need to say from typing import type var. So we're going to create type variables, and using type variables, we can have placeholders for certain types. So for example, I can say I have a type K, which is a type variable, and I give it the letter K. Then I have one which is V for key value. We're going to use those for key value. Or I can just say T is a general type T, and we can use those now as variables. What's the reason for that? What's the idea behind that? We can now say that if I have a function, for example, find in dictionary, and the type of the dictionary I pass is a dictionary that has some types K and V, key value, that then the value that I'm looking for has to have the same type V. And then we can say it returns none because it prints something or whatever. Or actually, let's return a Boolean. Let's, what did I do here? Delete bookmark. Let's return V in d dot values, like that. Then I can print here, find in, or yeah, let's first create a dictionary. Let's say that we have my dictionary where I have A is 1, B is 2, C is 3, whatever. Then I can say find in dictionary my dictionary, the value 2, for example. And in this case, I'm going to get true as a result. Now, how is this working? What does this do? Essentially, it says whatever those values are, whatever those types are, they have to be the same. V is the same everywhere. So it doesn't matter if that is an integer, if that is a Boolean, if that is a sequence, if that is a dictionary of something, if that is a TCP dictionary, doesn't matter. Whatever is V here has to be the same V here. So whatever I pass, if I pass a dictionary that has key value pairs of strings mapped to integers, if that is the case, then the value that I'm looking for has to be an integer as well. So this has to be the same value, whatever it is. This is why this is generic, because it doesn't focus on one particular type. It doesn't restrict me to use integers or strings or anything. It just says whatever I pass here has to be the same here. And the K is not really relevant here. So let me show you how this can be violated. If I say hello, for example, this still works, but MyPy is going to say that it doesn't work because that is not compatible. If I comment this out, if I only have that, then you're going to see that we don't have a problem because the type is the same. However, if I now change the type of this dictionary to strings of numbers, so if I keep the values but I turn them into strings, now you can see that this violates the type hinting. So you can see that I'm still gonna get the violation, but this time if I comment out that line, then I'm going to get everything is fine, because then this string here matches the string in the value side. So V and V is the same again. And this can be done with everything. You can do that with T, you can do that with X, Y, Z. You just create your type variables, and whenever you say something, if you have a function, my FCT, I'm just making up something right now, value 1 has to be of type T, and value 2 has to be of type T as well, but value 3 has to be of type K, and then value 4 has to be of type dictionary, T mapped against K. Those T's and K's can be whatever you want. They can be integers, booleans, sequences, optionals, whatever, but they have to be the same. Whatever value 1 is, value 2 has to be the same type, and in a dictionary, the key has to have the same type as well. Whatever value 3 is, the value of value 4, the value of the dictionary, the values, or what is it, the type of the values in the dictionary, that is value 4, has to be the same type as value 3. So this is how generics work. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and